Lesson 46, simplifying expressions with square roots and higher order roots. So I'm going to give you some examples of square roots first. So we can say that the square root of 49 is 7. If we have the negative square root of 16, that's going to equal negative 4. Square root of 0 is 0. Square root of 9/36 is equal to 3/6 or 1/2. Square root of a negative number, square root of negative 25, is there's no real solution. There is an imaginary solution, which is 5i, but we're not going to go into that right now. When you see square root of a negative number, you need to write there's no real solution. Don't write there's no solution, because there actually is, but there's not a real one. Those are square roots. Now we can look at cubed roots, examples of cubed roots. The cubed root of 27 is 3 because 3 times 3 times 3 equals 27. The cubed root of 8 equals 2 because 2 times 2 times 2 equals 8. The cubed root of negative 64 is negative 4 because negative 4 times negative 4 times negative 4 equals negative 64. The square root of negative 1 is no real solution. And that's like this one up here. There's no real solution. There is a solution. The actual solution is the imaginary number I. Now when you have the nth root of a number to the nth power, that just equals that number c. So here's some examples. We have the cubed root of 2 cubed. That just equals 2. The 7th root of 6 to the 7th is just 6. So anytime the index and the exponent equal each other, it just equals the base. When we take the nth root of a number, let's call it b, raised to the nth power, we can write that with the base raised to an exponent. And this m divided by n, the m is the exponent on the radicand, and n is the index on the radical. So here's an example. If we have the 4th root of 3 squared, if we wanted to show 3 with a fractional exponent, it would be 3 to the 2/4 power, or 3 to the 1/2 power, which is actually the same thing as a square root of 3. Here, the square root, the index is 2, and the exponent is 1. So the 4th root of 3 squared is the same thing as the square root. So if we had, let's show another example. If we have the 6th root of 7 squared, that equals 7 to the 2/6, or 1/3. 7 to the 1/3. And then if we wanted to write that as a root, we could say the cubed root of 7. if we had the square root of a fraction, that's not a 9, that needs to be an n. Maybe because 9 starts with an n, I don't know. Square root of a fraction is equal to the fraction of the square roots. And you can simplify by canceling if the radicands can reduce. So for instance, if we take the square root of 4/9, well, we can't reduce 4 and 9, but we could take the square root of 4 and then divide it by the square root of 9 to get 2/3. That's the end of the lesson.